Hey everybody. Today, what we're going to go through, you can see the title up at the top. We're going to work our way through some trigonometric ratios today. So this is really a follow-up to our last lesson where we introduced our trig ratios. So you got very comfortable, I'm hoping, with your sine, your cos, your tan. You've got SOH CAH TOA in your back pocket. But we also have an understanding about where that stuff came from. Today is about functionality, okay? Today is about how we use this. So today is going to be a day where we get to see why what we dealt with last time is so useful. So I want to go through not many examples, but I want to go through several problems. Then I want to have a little discussion as to how we deal with some stuff in real life. Okay, let's jump right in. You can see problem 1, I have asked you to find the length of x to the nearest hundredth of a unit. When I put that in that problem, this is going to be the only time that I do. We are going to have a rounding rule in the class. That is, anytime you are looking for a side length, if the problem does not tell you how to round, then you always round to 2 decimal places. Okay, that is our rule. That's what we are going to follow. So I have asked you to find the length to 2 decimal places, and you can see on the 2 diagrams in front of us, x. Okay, I want to talk about problem A. You will notice that for us to have this problem before, you could not have found x. That is, you would not have had enough information on your triangle to be able to solve for x. First thing you look at, hey, it's a right triangle. So you know your side lengths have to fit in the relationship of Pythagorean theorem. But the problem is you would have needed to know that purple side in order to find the other side. You always needed 2 side lengths to be able to find the third. Well, now that we've got some trig ratios at our disposal, because you have an angle given, that is now enough. The fact that we have a right triangle with a side and an angle given, we now have enough information on that triangle to be able to come up with any of the missing sides. Okay, I want to walk through what this solution would look like, and then I want to point out some of the things I would need to see in your answer. Okay, the first thing that I want you to do, if we recognize that we don't have 2 sides, so we can't use Pythagorean, then the first thing I note, it's a right triangle. So I have all of my right triangle trig that I can use. That means I have my SOH CAH TOA. I'm going to ask you to fight the urge to write SOH CAH TOA at the top of every page. I know some people are going to be told, hey, go ahead and do that. That's a great technique. Put it up there so you can see it. Stop. If you know it well enough to write it on the page, then I want you to just start using it. So we are going to go through with nothing written up at the top of that page. We see a right triangle. We say, I know we've got SOH CAH TOA. What I need everybody to do now, and this is the last day I'm going to tell you to do this, take your non-writing index finger, just as we did last time, and put it on the angle. You can see I have highlighted in purple where my non-writing index finger would go. Because if I look at my right triangle from that perspective, I now have names for my sides. You will notice that the side I am looking for is opposite. I'm going to label it this one time only on my triangle. The other given side, that is the other side where I know the measurement, is my 20. That 20 is my hypotenuse. So what I'm trying to think of now, okay, which trig ratio includes opposite and hypotenuse? So I need which one of those three little acronyms has an O and an H. And I'm hoping we go, hey, that's the SO part of SOH-CAH-TOA. Sine is the ratio that we need to use. So we are going to use our sine ratio. What does that look like for a solution? Well, that means that we can say that the sine of 35 degrees, remember, my non-writing index finger is on that purple angle, has to equal, and the way I calculate my sine is to say it's my opposite side, x, over my hypotenuse, 20. There you go. That is your equation. And if you notice, that equation is going to look a little different than equations you're used to, but I hope we can see there's only one variable in that equation. If you recall from last time, sine 35 is a number. Like it's an ugly number, but it's just a number. That's a constant. So the only variable I have in that equation is my x. And that's what I have to solve for. So let's get it all by itself. What that means is I have to get rid of my divide by 20. How do you get rid of a divide by 20? You multiply by 20. So what I'm going to do is I'm going to multiply out my 20. That now gives me 20 sine 35 degrees. Okay, couple things in terms of our notation. I want you to notice I don't write 20 times sine 35. I don't need to write the multiplication symbol in between. I know that if I don't see an operation, that multiplication is there. The other thing, you'll notice that I put 20 out in front and I wrote it as a coefficient. The reason why I did that is because when I write sine 35, 20, okay, that looks weird. So let me get rid of that 20 and now write times 20. That can look a little confusing. Like, is that times by 20 on the inside of the sign or is it on the outside? If you're not sure what I'm talking about, is it my green brackets, which is what I really want, or is it my orange brackets? Now, you might be looking at that and going, 35 times 20, how could that ever be on the inside of my sign? Do me a favor. Take your calculator, punch in 35 times 20, and then take the sine of it, and you're going to see something weird happens. So, if you recall, math people are lazy. We don't want to write stuff down if we don't have to. And so you'll notice that by me putting the 20 out in front of the sine 35, I don't even have to worry about brackets. It is clear to my reader that that 20 is outside my sign. Okay. Now, what you just wrote in your last line in red, that is the exact value of x. It is perfect. There has been no rounding that's happened. But if I asked you, hey, how long is 20 sine 35? Then you should look at me weird. Because that is not the way we talk. If I told you that x was 20 sine 35, you should look at me weird. That's not understandable. So what we do is we follow that instruction and we round. That's the way we talk about it. So you are going to go through your keying sequence however you have to. Last time we were just trying to figure out how to punch in ratios. Now we have an operation. If you have a forward calculator, you can punch in 20 sine 35 right away. And you are going to get an approximate value of 11.47. If you have a backwards calculator, then you are probably having to punch in 35 sine, and when you hit that sine button, you're going to get a big ugly decimal that pops up on your screen. Now you have to hit times 20 equals, and that's going to get you your value. Okay, you figure out your keying sequence, but we should be coming in on the red. And the only part of that problem that I have not completed is it matters what my units are. So I look back up on my diagram. I can see that we're talking about meters. Since this is a ratio of the same units, then there are my meters. What you see in red, I need to see for your solution. You have to show me your application of your SOH CAH TOA. That's what allows you to build the equation. You have to show me the exact value for what x is. That's perfect. Then we have to round it off for the way we talk about it. Okay, there we go. You guys just used trig for the very first time, I would argue, to do something, to find a missing value. Nice. Okay, we could be at the point where you're ready to try a problem on your own. So, I'm going to ask you to try. Challenge yourself. Can you give B a shot and see if you can come up with the value for x? Don't worry about what you include for your solution. Just try to mimic what we did on A. Okay, try it on your own. Pause the video now. Okay, we're back. So, you take a peek. I'm going to ask you to do the same thing we did before. I want to go through, you take your non-writing index finger and put that on the angle, because that's what's going to drive our perspective. You go through, because I am looking at that triangle from that 20-degree angle, that now says that my 9 is my adjacent side and my x is my hypotenuse. I told you I was not going to write the labels on the triangle. I'm not going to write them. I'm just going to keep it up in my head. So I'm thinking to myself, I have adjacent and hypotenuse. That's A and that's H. Which ratio am I talking about? And I say, I got it. That's my cos. There's the CA part of SOH CAH TOA. So I know that I have the cos of 20 degrees. That has to equal my adjacent over my hypotenuse. There we go. If you're able to come up with that equation, outstanding. That should give you some comfort. Hey, you know your SOH CAH TOA. Okay, the rest now just becomes algebra. Really, that's like the end of our trig. So, you will note one important thing. When you look at that blue equation, my variable is on the denominator. That means I have to get it out of there. So I'm going to have to multiply out my x to start this thing off. To do that, I'm going to write in a green line. I never have to see that line as part of your solution. Because you'll notice, for me to solve for x, I now have to take that cos 20 and I got to divide it out. To get the XL by itself, I have to get rid of a times by cos 20, so I need to divide by cos 20. If you can do all of that in your head and you get quite comfortable with it, then I think you should be okay to just show me the blue. Show me the first line. There's our application of SOH CAH TOA. Now, if we can see, you're going to multiply out the x while at the same time dividing out the cos 20, you can jump straight to that last blue line. That is the exact value for x. But again, we don't talk about it that way, so let's change that into a decimal. Okay, your keying sequence, again, is going to be a little uglier. If you have a forward calculator, I am going to argue to you, this is about as easy as it could be. You're just punching in 9 divided by cos 20. you're going to get an approximate of 9.58. However, if you have a backwards calculator, this one can be a bit of a pain because of the nature with which you have to punch this stuff in. It's going to likely require one of two things, either an answer button or you got to use brackets. So if you have a backwards calculator, then maybe if you have an answer button on your calculator, one that stores the previous answer, what my recommendation to you would be punch in 20 cos. Okay, I never write that, but that's my keying sequence. That's going to calculate cos 20 for me. Hit equals. That puts that value into your calculator. Now, punch in 9 divided by, and here's where that answer button comes into play. If you can punch in your previous answer, now that should get you to your 9.58. Okay, if not, and you don't have an answer button, then what you're doing is you're using brackets. So you're going to punch that in the way it's written, 9 divided by, but now is where you need to open up a bracket, maybe. Then you're going to punch in 20 cos, close your bracket, maybe, and hit equals. That will get you your value. On some calculators, you won't even need those brackets, but what you have to be very conscious of is that when you punch in 20 cos, most calculators are going to automatically spit out that decimal value. So you have to be very conscious that when you punch in 9 divided by 20 cos, the first number that pops up on your calculator screen is not your answer. It's the value of 20 cos. You then have to make sure you hit equals afterwards to get your approximate answer. Okay, a lot of different keying sequences. You need to figure out how your calculator gets you to 9.58. We make sure that we keep on our units, and there you go. You give me the blue lines, and you have a perfect solution. How do we do? Okay, we took a long time to get through the first 2 problems, but I'm hoping that the pace that we did that with, now you can just duplicate these solutions as we go. Okay, let's jump into the next problems. Okay, you take a look at problem 2, and you will notice that your instruction changed. You are not finding a side length anymore. Question 2 says find an angle. And just the same as what we did in our problem 1, that is our normal rounding rule. So unless the problem says otherwise, round to the nearest degree, no decimal places. Okay, let's work our way through A together, and then we can try B on our own. You're taking a look at the diagram in A, and now we need to put our non-writing index finger on that angle, because from angle A, you now have named sides. You can see that side 6 is your opposite. You can see that side 3 is your adjacent. Opposite and adjacent is O and A. OA, there's my tan for my TOA, tan. So the equation I can write then is that the tan of A has to be opposite over adjacent. There we go. Okay, I wanted to go through this one for 2 reasons now in terms of our solution. You will notice that 6 divided by 3 does reduce. I don't have to see that line. I don't need to see it. I don't care whether 6 divides by 3 evenly for where we're going to go with it. So don't ever feel like you have to write that. You can stop at the purple. Okay, this brings up a problem from last time, and we're going to see what we remember. Notice you have to go backwards now to find the angle. If you remember, every time you hit sine, cos, or tan, that's a ratio. That means sides. Now you need to go backwards to go backwards, you have to deal with the inverse. So A is going to be the inverse tan, and this might be a time where I write down 2 out of laziness. Like, it's faster to write down 2 than 6 divided by 3. Again, though, I don't care. If you wrote down 6 over 3, fine. There is your button pushing sequence. You now need to go through and calculate that. So we're taking the inverse tan of 2 or 6 divided by 3. You now give me that A is approximately 63 degrees, and you are good. Remember, we're rounding to no decimal places. Okay, you'll notice that I put that middle line in red. I put that there because I don't need to see it. This is going to become so commonplace, you going backwards to find angles, that should just be a given. So if you gave me the 2 purple lines as your solution, perfect. That's all you have to show. Okay, I think you are ready to go ahead and give B a shot. Okay, try it on your own. We'll see how we match up. Pause the video now. Okay, we're back. Everything starts from the angle out. Now, I should say, like, really, I am looking at this going, hey, it's a right triangle. Therefore, I know I have SOH CAH TOA. So I go to my angle. I'm getting a little ahead of myself because I'm just dealing with the world I'm living in. Soon as we put our non-writing index finger on our angle, we can now see the opposite side, we know, and the hypotenuse, we know. Opposite and hypotenuse is sine. There's my SOH. So, that was horrible. Sine of A is going to give me my 15 over 20. There is my opposite over my hypotenuse. Same thing as what we talked about before. Could not care that 15 over 20 reduces. I now need to find A, so I have to go backwards and take the inverse sign. I never need to see that A value, so please do not, that red value. So again, just like before, don't ever feel like you have to include it. I don't want to deter you though. Like if you like to write it, write it. And now I can calculate. And if I round to the nearest degree, we should have got 49 degrees. Like your answer should have been 48.5900, round to 49. And there we go. Okay, I'm hoping that we're doing okay. Things picked up a little bit. Maybe we found it was a little bit easier to go backwards and find an angle. Okay, what I want to do now is I kind of want to test ourselves. Like I actually think we're ready for that. So let's play through a few more problems. We're going to really pick up the pace. You're going to try every single one of these on your own. Okay, here we go. Okay, take a look at your instruction for 3. You now need to find the length of X or find the indicated angle. So everything's jumbled up. Find a side length or find an angle, depends on the problem. Okay, you jump in on A. If you're feeling super brave, then tackle both A and B, and then we'll come back and we'll see how we match up. Okay, pause the video now. Okay, we're back. So I've got a right triangle, so I know that I can use my SOH CAH TOA. I take a peek and I focus in on, there is my angle. Because that's my angle, that side becomes opposite. That side is adjacent. Opposite and adjacent is TOA. There's my tan. So I can write my equation to say that the tan of 40 degrees has to be opposite over adjacent. There's your application of trig, your SOH CAH TOA. That tells you whether you have your trig down. The rest is your algebra. So you could show me this line if you want. That is multiplying out your divide by x. I need to see x isolated. So make sure that you show me that x equals 15 divided by tan 40. And now the rest is button pushing. You go through, we know that we are finding a side length. Up in the problem, there's no rounding rule. That means I round to 2 decimal places. And for that then, I'm going to get an approximate, make sure we're marking our approximates, 17.88, put on my units, and I'm good. There we go. Hopefully not too bad. Hopefully yours matched up. Okay, let's jump into B. If you don't have a solution to B, then pause it now and work your way through. Otherwise, we're going through together. Same thing, we are noting, there's the angle you are looking for, angle A. From that angle A, that's your hypotenuse, that's your adjacent. Adjacent and hypotenuse is cos. So the cos of A is adjacent over hypotenuse. Okay, you may choose, if you want to tell me that A is the inverse, because we have to go backwards to find the angle. However, you can just find your approximate, as we've already noted. Make that calculation, and if you come in on 37 degrees, great. Okay, I am hoping that those two went well, and you're starting to feel more and more confident. Notice, if you do not know your SOH CAH TOA, then you're going to really struggle with this. That we need to make sure that we get tons of practice applying SOH CAH TOA. You have to know your SOH CAH TOA definitions. Okay, let's tackle the last two. Okay, we get another chance to try these on our own. This is building up our problem solving. Okay, pause the video now. Okay, we take a peek. There's my angle. From that angle, I have my opposite side and I have my hypotenuse. That is sine. So the sine of A, opposite over hypotenuse. Okay, I can now show that A is the inverse sine. Well, hey, 6/12 is exactly 1/2. Maybe I just write down 1/2 because it's faster. And now when I go to calculate my A and I push my buttons on my 1/2, hey, wait a second. I really got into the habit of something, of me marking that answer as an approximate because I've always got these ugly decimals. Hey, wait a second. That wasn't approximately 30. That was exactly 30. Hey, this is one of those special things that popped up, similar to what we talked about last time, where we don't get an ugly decimal. Ah, nice. That one might be one to put in my back pocket. Okay, you show me the blue, you are good. Okay, let's jump into D as our last one. So you take a peek, D. I'll do that in purple. There's my angle that I'm focusing in on. And from that angle, I have opposite and I have hypotenuse. There is my sine ratio again. So my sine of 47 is x over 12, opposite over hypotenuse. Okay, for me to get my x all by itself, I have to multiply out my 12. And now I need to turn that into a decimal so I can talk about it the way most people talk about it. I'm hoping you get down to a rounded 8.78. Put on my units, and I'm good. Okay, there you go. There is us using our trig ratios. Now, I made a point at the beginning of the video that I wanted to kind of talk about one thing for how we use this. I made a comment in our previous video about this might be the most applicable topic that you ever use in math. Like, for all those arguments of like, when am I ever going to use this stuff? This is the stuff you use. And us seeing the practical application of it, I think should be pretty straightforward. I want to go through this pretty quick. Okay, you have a blank screen sitting in front of you right now. There's a part where I want to ask you, how do you think people go through and calculate extreme distances? Like, let me give you an example. In Toronto, and I'm going to draw my crudest CN Tower. There is my CN Tower. How do you think people know how tall the CN Tower is? Do you honestly think that someone stands up at the very top of that thing and they hold out a little tape measure and they drop the tape measure all the way down to the ground and somebody catches it and now they pull it taut and somebody reads the tape measure off the top? I hope not. Or was it a ball of string and somebody just throws the ball of string down? No. Okay, that's not how we find that height. Okay, how do you find that height? Well, I don't do any of that. Instead, what I do is I come a certain distance away from the CN Tower, and I measure that distance. I know, I don't know, I'm just going to call it 100 meters. Let's call it 100 meters. Then I take a device that measures angles. We can use a little handheld device called a clinometer or a thaloscope, and I can read through that device if I went, what is the angle that I create from the ground as I rotate up and I hit the top of that object? And when I read that angle, then maybe it says, hey, that's 70 degrees. Well, if I know how far I am away from an object, and I know this angle of elevation to get to the top, then that vertical object forms a right triangle. So look what you got. If I want to solve what is x, then from that angle, I now have opposite side, adjacent side. That's tan. The tan of 70 degrees is x over 100. So x equals 100 tan 70. And so x equals approximately 274.75 meters. Well, that's a pretty big building. But that's the process that we use. So if you are looking for something that is applicable every day, you're not going to find anything more than trigonometry. Okay, I hope that you can see the value in what we're covering right now. Your job, you want to get really, really good, to the point where it is automatic. You can almost shut your brain off with your SOH CAH TOA. Be able to build your first trig equation. Be able to build that trig application. Know your SOH CAH TOA, build your equation, let your algebra skills take over. Okay? The only way to get great at this is to do 1 million of them. So jump in and get some practice. Best of luck.